Hello everyone, welcome back to Pitt Tonight. Today we are at the Gowan Institute for Regenerative Medicine and we have a very special guest again. Here she comes. It's Dr. Ambrosio!
Welcome, Victoria.
Thank
nice
you.
To see you.
Thank you for having us. Can you tell everyone why are we here today?
We are here to give you guys a tour of our home away from home where we have our laboratory within the McGowan Institute for Regenerative Medicine.
Awesome, well let's get started.
Let me show you around. Okay, so let me show you the lab where really the engine and the energy is. Here are some people from our group. Maybe I'll let them kind of introduce themselves.
Okay, awesome.
First. We're very polite. After you.
Hi, I'm Cam. I'm a lab tech.
Awesome.
Hi, I'm Angelica. I'm also a lab tech.
And Amanda, I'm also a lab tech.
Great. For those who don't know, what does a lab tech do?
So as a lab tech, we kind of assist on a lot of the projects. Like whenever people need hands, we help out with different things. So we all have like specific projects that we're mostly like working on, but we're able to kind of like be flexible and help each other out. We also just help like keep things organized and clean in the lab, do like general lab things as well.
Awesome.
See, if you ask me, these guys are the bones for everything that we do. They kind of support all our projects and really help keep everything running smoothly. So definitely essential to our team.
Oh, well, that's amazing. And the lab looks beautiful. So
That's
really
also they're doing.
Yeah, well, speaking of all the different projects that the lab is working on, are there any in particular that are exciting, that you're really excited about right now?
Oh, I'm excited about
sure
all of them. Where to start? Actually, we can take you. I can show you some of the things in the culture room, and we can tell you about some of the projects.
Okay,
How's that
awesome.
sound?
So when you say culture, what is that referring to?
So mostly we work with stem cells.
Okay.
And specifically muscle stem cells.
Oh, okay.
So the cell population in our muscles, our skeletal muscle, that is really responsible for healing muscle after an injury or even with disease.
Yeah.
These are kind of the reserve troops that come in and really help us get back to where we were in ideal circumstances. And so here in this culture room, essentially what we do is we isolate muscle stem cells, and here's where we grow them and expand them and take a look at them. Actually, we don't have the magnetic coils in here.
Okay.
But we have a really cool project. So one of the projects, and we can show you some of the equipment that we're developing. It's specialized equipment, so super excited about it. And actually, I can tell you the origin of this project is inspired by birds and their migration.
Okay.
So have you ever wondered how is it possible that birds can, from somewhere in the north, migrate a very specific direction for hundreds of kilometers?
I have wondered.
Have you
this,
wondered
And I
it?
also don't know. They all coordinate, and then what if one of them gets tired?
It's an
I don't
amazing
know.
question,
Yeah.
right? So, so I think a really interesting question that's been asked for decades really is how do the birds know where they're going? What is this internal GPS that they have that they all together can say, we're headed that way? Well, it turns out that there is more and more evidence suggesting that birds are actually able to sense the magnetic field from the Earth.
Wow.
And so depending on their geolocation, they can say, here's the intensity and the direction of the magnetic field. So that kind of orients them where they're going. And so they use those cues to be able to migrate.
Wow.
Now, we're kind of building on some of those findings, and the questions we're asking is, do cells in our body do the same thing?
Oh, wow.
Because actually our body has magnetic fields all throughout, right? We have magnetic fields are kind of in our brain and our heart, all throughout our bones, our cells and tissues. And so now we're actually wondering if cells may tap into some of those endogenous magnetic fields in a very similar way that birds use the Earth's magnetic fields for migration.
Wow. So is that what the magnetic coils and everything
Yeah,
is
can I
testing?
show you
Oh,
where those are? I
please.
think that would be really fun because this is something that was custom designed by our colleagues in the Department of Physics. looking for those magnetic coils that Gabby had.
So it's 2 bays down, right?
2 bays down. Okay, let's
So
introduce
is each
you.
of these a bay?
Yes, so each of these are a bay where we do a lot of the lab bench work. So this looks super mad scientist-y, right? That's why I love it. Yeah, their hairs are just too nice. We need a little bit more Einstein hair, and then we'll be legit.
Oh, could you introduce everyone?
Yes. Allison, go ahead. I'll let you introduce yourself.
Hi, I'm Allison. I am a junior faculty member. So I am both a clinician and a scientist. So I'm learning some new things from Dr. Ambrosio and trying to eventually branch out on my own. So.
And I'm Gabby. I'm an MD PhD student in the lab. So I'm a full-time grad student right now, and yeah, working on a couple of projects.
Awesome. Well, Dr. Ambrosio was telling you about these coils, right?
Yeah. So one of our projects is looking at how magnetic fields affect muscle regeneration. So in order to do that, we need to be able to control the magnetic field, and in order to do that, in collaboration with some students in the physics department, we now have these Helmholtz coils. And so basically there's current sent through each of these little loops, and so that we can generate a magnetic field in the direction that we want. And so if you come over here, this is where the cells will be in the incubator. And then there's this little sensor down at the bottom that you can kind of see with this green light. And that actually measures the magnetic field to make sure that it is what we want it to be. And then, there's once I get the computer pulled up, there's a code that will change the amount of current going through these wires so that the magnetic field stays at whatever we set it to.
Wow. Is the magnetic field dangerous? Like if you were to put your hand in there while it's going?
No.
Or?
If you put something that's magnetic in there, then it would probably fly off. But we're also looking at strengths of fields that are extremely low, like on the order of Earth's magnetic field or lower, which obviously an Earth's magnetic field, we're not flying everywhere. But if we put a very strong field in here, then and if there was something magnetic, then it would fly away.
Got it.
Yeah.
Wow, this is super cool. And yes, absolutely very mad scientist. The whole setup, all the wires. No, that's really cool. How long have you guys been working on this?
So this is actually a project that's funded by the Department of Defense. And so I think that started in September of last year. We've been generating ideas and kind of brainstorming with our team for longer than that, but the actual official start of the project was fall of last year.
Wow. Super exciting stuff. I do see something in the bag. I see this giant photo of you. What's going on with that?
She won this amazing award for being
the most influential woman in all of Pittsburgh.
And so we wanted to, keep that.
Is that from the gala or? Oh, it's lovely.
It was against mine.
I initially had you looking out onto the world, but someone took it down.
Oh gosh. They insisted on bringing them back from the event, but much to my dismay.
No, it's perfect. I'll bring one next time. I'll make my own.
Here you go.
Yeah.
So I don't feel so lonely.
Oh my gosh, wow, you guys just have very interesting and amazing progress and projects. So thank you for sharing. Yeah. Is there anything else in the lab you want to show us?
Yeah, let me introduce you to some other people here who you haven't met yet. So this is Kai. I'll let you introduce yourself, Kai.
Hey, my name is Kai Wang, and I'm a postdoc here. I've been working in the lab for about 3 years, and my project is regarding the building a in vitro muscle model to kind of like mimic the muscle aging effect, the effect of aging on the muscle biology. So, yeah.
This is another project. Kai is doing an amazing job with this project. So the idea is we build mini muscles in a dish. And so, as you can imagine, this is a really great way for us. We don't have to worry about using so many animals. Of course, that's something we always worry a lot about. So with just some cells, we can build these mini muscles. And Kai's idea has been to use these muscles in a dish to test out different interventions, drug interventions, even different stem cell interventions as a way to improve muscle healing. Specifically, he's looking at aging because we know that muscle stem cells just don't work as well as we get older. And so Kai's really interested in developing new technologies to improve healing capacity in older individuals.
Wow. That's amazing.
Yeah, it's pretty cool because his muscles, not only do they look like little baby muscles, but they're tiny, and they just contract on their own. So you can actually see them. He has some videos I'm sure he'd be happy to share, but it's neat because they just, spontaneously contract, especially the young ones. And then the old ones, you can tell that they're just trying.
Yeah.
They contract a little bit, but not nearly as robustly.
What do you consider old for the muscles?
It's old, like we got the cells from young mice and old mice, which is like young mice is 3 months old, 3 to 5, and old mice is 21 to 23 months old. So we got the cells from those muscle tissues, and then we culture them a little bit and culture them in a 3D environment to give them kind of like a muscle mimic conditions, and they will kind of form a muscle-like structures in individual. That's kind of how we do that. Yeah.
Oh goodness, I wonder what you'd classify my muscles as then.
Oh yeah, no, you're definitely. So the young mice that we use would be about a young adult, and then the old mice are probably around 65 to 70. So you've got
I'm like a young
time.
mouse.
You've got
I'm like
a very
young
long
mouse.
time, Victoria, until we're going to be worrying about your muscles being weak.
Good. Well, is there anything else in the lab you want to
Let's see. We have some more people here. Amrita and Zach, for you to say hi. Oh, Zach is not here. He was here a second ago. Oh,
Not here,
So Megan is one of the only undergraduates who are representing today. I don't think we have any of the other undergraduates who are in the lab. But actually, Amrita and Megan are working on another super cool project, moving away from muscle and more into brain. So I don't know if you guys want to introduce yourselves and tell them a little bit about the Brain on a Chip project.
Okay, so I'll introduce myself, but I'll let Megan, talk more about the Brain on a Chip. I'm a junior faculty, Amrita, and I work with Fabrisia Ambrosio. And this is our undergraduate student, Megan, who is sort of leading the Brain on a Chip design and construction.
I can talk about that. So, hi everyone. I am a senior at CMU studying chemical and biomedical engineering. So I've been working on the Brain on a Chip project. So basically we're trying to design this microfluidic chip. It's like a really small amount of fluid moving past brain cells. And lately we've been doing computer simulations before we've started to build the chip, and we're finally starting to work on that now. So super exciting.
That's really cool. Awesome. Thank you guys. That's really awesome. I don't know. We lost her. I'm lost in the lab. We'll have to find her. I think, we found her. I'm unshackled.
Okay. That was one more person that I'd love to introduce you guys to. Zach is one of the newest additions to our laboratory.
Yes I am. How are you guys doing?
Oh, good. Well, tell us about yourself.
So I just started in the lab last summer. I'm a postdoc. I just arrived. Then I work on aging stem cell biology, particularly how we lose stem cell content with age. We kind of have a few different approaches to how we look at it, but kind of run through experiments right now, actually trying to answer some of these questions. So, yeah.
Awesome. Yeah, we were talking about muscle age a little bit earlier with Kaiwen, and we were saying that I have muscles similar to a young mouse in age.
Well, good for you.
So
I think we all should strive for that.
I think that I'm riding that for the rest of the day. I'm really excited.
Yes, and I hope you do. So we're trying to figure out how you can keep your muscles young and
so
also...
I can stay like a young mouse forever.
Yes, we're all trying to stay like young mice.
Okay.
Absolutely correct.
Awesome. Great.
Yes.
Cool. Awesome. Well,
Cool.
very cool. Thanks for being with us today.
Absolutely. It was nice to meet you.
What I didn't tell you is that he is a walking reference manager. I mean, he
Okay.
knows every article you can imagine.
Wow.
You tell him, wasn't there a paper about this a few years ago? Yes, you're talking about, and he'll give you the year, he'll give you the author, so really, has really made a contribution to the group.
Yeah, Fabi. So everybody has their own role in the lab, and what I've decided is that I need to store at least 10% of my brain to kind of be a little Google, just to be. That's my version of lending a helping hand. So. Normally 7am runs around, hey, have you seen this article? I'd love to share it with you, even if you don't want to. So, but yeah, it's kind of a team effort. That's my role.
Awesome. Well, that sounds like a very important role.
Thank you. I think so too.
Wow. Yeah, good. I'm glad. Awesome. Is this the team?
This is
the
most of
team.
the team. Not everybody could be here this morning, but this is most of us. Yeah.
What a super team you have.
It's an amazing team.
Yes, it is.
Just a great dynamic. One of the things that I love is that everybody is kind of working together, supporting each other on the different projects, and so they're co-authors on each other's work, and I think that really kind of sets up a nice environment. We probably have more parties and potlucks than any lab on campus. I have to say, I think we hold the record. There's always a reason for us to socialize.
When we started, I think I had to start going through my cookbook and start bringing out new recipes.
Yeah.
Because we did 3 potlucks, I think, in the first month.
Oh my gosh.
Yeah.
A lot to celebrate.
That actually has been a running joke in our lab. Is one of the interview questions is, how good are you with a recipe?
Oh wow.
I
What's your
would
go-to-
not
what's
get a
your
job.
go-to recipe?
That's the thing, Victoria. I would not get a job because I'm a terrible cook. So.
Well, what does Zach bring? What's your go-to thing to bring?
I did stuffed mushrooms for the last one, and it was a hit. That one was really good. I did bacon wrapped jalapenos that could have been better. We're going to work on that for the subsequent visit. But if you can follow a recipe, you can follow a protocol. So if you're good at science, you're good at cooking. It's the rule of thumb. But it is not a prerequisite either. Shots are not fired at Baby. Shots are not fired.
I accept them willingly. I'm the first to admit it.
I fully would go to Giant Eagle and get something and put it in my own bowl and be like, guys, I totally just made this mac and cheese from scratch, so I hope you enjoy it.
Remove the stickers.
Yeah.
Any evidence. Yeah.
Yeah. Awesome.
So I think those are most of the team members. If you guys want to walk just around a little bit to see a little bit more of the building, I don't know if that's interesting for you.
Yeah. Well, thank you so much for having us in the lab and giving us such a great
Yeah.
tour. Again, you have a really amazing team, and it was so cool to talk to everyone, hear about their projects, and see some of the projects too.
Thanks so much for coming.
Yeah, and again, also thank you for being on our last episode.
I
so
love
many people,
doing that.
So many people loved having you on. Loved seeing you. So thanks for having
No, you
me on
guys
again.
made it a lot of fun.
You're very popular, so thank you again. And yeah, this has been our extended interview with Pitt Tonight. Yay.